Okay, so how do you know it's linear? It's based on the format of the equation. There was only a few that we learned. Linear would be in that y equals mx plus b format. The x squared means that it would be quadratic, and then the absolute value symbols, it would be an absolute value equation. So we'll go through each of them one by one. So this one's linear. Parent function would just go through the origin and have a slope of 1, and then for this one, it's just 3 units up. Then something else that was on our notes, and we'll just jot it down here, is y equals a x minus h squared plus k. And I'm pulling this from chapter 2. Even if you want to make a note so you can make yourself more notes, it's lesson 2-7. Okay, so in this format, this is the vertical change, up or down. This is the horizontal change. And notice the negative symbol is part of the equation, it's not part of the h. And then this would be the stretch. And then something that comes up in another problem, if this is positive or negative, it's reflected up or down, but that comes up in another problem. So for 23, we have y equals x squared minus 3, so the x squared means that it's a quadratic, which means it would look like this format. And then graphing it, the parent function would just go through the origin and just graph up like this. But this is minus 3, so it's translated 3 units down. Translated down 3 units. So we go down 1, 2, 3. And then it'll just be like this. So as you know, the exam's multiple choice. You're looking for the graph that looks like this, that has a point at -3 on the y-axis. And then you're also looking for the statement translated down 3 units. Okay, next. Okay, now we're graphing inequalities. These graph just like linear equations. In order to graph them, we need to have it in y equals mx plus b format. Plus b. So we're going to take the x, put it on the other side. Like this. And then once you have it like this, then you can graph it. So you might make a note on graph paper. So if you're looking at this as you do the exam, just make a note that you put the rest on the graph paper. And we're going to graph it on the graph paper. So this is Algebra 2, Semester 1, Exam Review. And starting with 24. And the equation I'm graphing is this. And this one kind of ends up in the lower portion of the graph, so making it like this. Okay, and then in graphing this, y-intercept at -4, 1, 2, 3, 4. Slope is -1, so that's down 1 over 1. And then you have to consider whether you're doing a solid line or a dotted line. Something with a line under it is a solid line, and then without the line, it would be dotted. So for this, we're going to do a solid line. Okay, so with this, I encourage you to kind of say it out loud because then you know where to shade. Y is less than or equal to this. Y is less than, so we shade below. Okay, and this for points. And you get to use it on the exam. Okay. Okay, next. 25. I have to rearrange the equation so I get it in y equals mx plus b format. Remember, if I divide by a negative or multiply by a negative, then the inequality changes direction. So this, and then divide by -3. So inequality changes the other way. 1/3 x minus 2. Okay, zooming out again. Now I'm going to graph this one. 25. The equation is y is greater than or equal to 1/3 x minus 2. So y-intercept at -2. Slope of 1/3 up 1/3. Consider whether it needs to be a solid or a dotted line. It has a line under it, so it's solid. And y is greater than 1/3, so I shade above. Make it darker. Okay, next, 26. 26, now we're bringing in absolute value. The absolute value graph, as you may remember, looks like this. The same translation rules apply, so this -1 means we're going to just like shift down 1. For this one, I'm actually just going to graph it here because it's simple enough. So here is my graph. My y-intercept is at -1. And then there's no coefficient here, so the coefficient's 1. It's just up 1/1 for absolute value. It's shifting down 1 from 0. So like the parent function would be at 0. And the -1 is just down 1. Or y-intercept at -1. Then from here, I need to connect my dots. There's no line underneath this inequality, so I'm going to do a dotted line as best I can here. And y is greater than that, so we shade above this. So as far as the answer choices, it's already going to be graphed, you're just identifying it. So you'd be looking for a graph with a point at -1 and then a dotted line. (27) is a little bit more complicated. It brings everything together. Before we graph it, I'm going to pick it apart. This -2 means down 2. The plus 1, remember it's opposite, so it's actually left 1. The 3 is a stretch. And then the negative means reflected down. And then we're going to graph. So make a note for yourself on graph paper. Actually, I just folded my graph paper so that way I can have the problem and the graph in the same frame. So for 27. And most of the graph is in the bottom part of the coordinate plane, so I'm just kind of skewing my graph like this. Most of it lands over here. Okay, so starting with the original point, down 2 to left 1. So down 2 to left 1 point. Then the stretch is 3. It's reflected down. So it's reflected down, meaning that it's going to be like this. And we're going to go down 3 over 1.
The stretch is almost like the slope of it?
Yeah. And then it's a dotted line. I'm just saying it out loud. Y is greater than this, so we actually shade above all this. Okay. Next. Am I going too slow or too fast? I don't know. I feel like I should go faster because it gets boring, but then people say, oh no, slow down. Okay. Solve each system of equations by graphing. So when they say solve each system of equations, they're asking where they intersect, where the equations intersect, or where the lines intersect. In order to find that out, we need to have this in a format that we can actually graph. This one's fine. It's in y equals mx plus b format. This one is not, so we're just going to rearrange it. Y equals 1/2 x plus 0. So now I have my two equations that I'm going to graph. 28. So y equals 2x minus 3 and y equals 1/2 x. Y equals 2x minus 3. My y-intercept's at negative 3. Slope's 2, so up 2 over 1. For this equation, y-intercept's actually at 0, and then slope is 1/2, so up 1 over 2. So it looks like it intersects right there. So our solution is at 1, or 2, 1. Yes. What's that? I just graphed the two equations. Yes, Kate.
Do you do a dotted line for the other one? Or does it matter?
No, because it's an equal sign, it's equal to.
Okay.
Sophie, where did you?
Just when you did the other line. The other one.
This one here?
Yeah.
So it would be like plus 0, so the y-intercept is 0. And then the slope is 1/2, so up 1 over 2. Up 1 over 2.
Okay.
And then that's the solution. Again, where it intersects is your solution. So 2, 1 is what you'd be looking at for in the answer choices. 29. 29. Okay, 29, same type of problem. We just need to graph the 2 lines. This one we can graph right away. It's just like a horizontal line at y equals 1. Yes, Robert?
Can you show it just one more time?
Okay, and then this one needs to be rearranged so I can graph it. So I'll just put x on the other side, y equals positive x plus 3. So I can graph this and y equals 1. So 29, I'm going to flip this over.
Is it negative x or x?
When I put x on the other side, it becomes positive.
Sorry, yeah, you said, I heard you say negative.
Yeah. Oh, add x to both sides, yeah.
Threw me off.
Okay, y equals x plus 3, so y-intercept would be 3, a slope of 1. And then for the line y equals 1 right here, and it's just a horizontal line where y always equals 1. And then where it intersects, it looks like it intersects right there. That's going to be our solution. So that would be at negative 2, 1. Okay, continuing the same concept with the next ones, of course it just builds. It says solve each system of inequalities by graphing. When we solve inequalities, we're not looking for one specific point where it intersects, we're looking for like an overlapping section. So we're doing the same thing where we're graphing 2 lines and then we'll be looking at where the shaded parts overlap. So for number 30, we need to make sure that they're both in formats that we can graph. X greater than negative 2, we can graph that right away. But this one, we need to rearrange a little bit. We need to get y by itself, so divide both sides by 2. By the way, we're only doing this, the rest of this page, and we're done. Because it gets long. Okay.
For what?
We're finishing this page, and we're done. So we have 3 more problems. Y is greater than or equal to 3 halves x plus 3. So I'm graphing this, and I'm graphing this.
So,
Yes.
Gage is correct.
Oh, what's up, Gage?
So for the x and like the negative 2, if like the x is on the like the x is by itself and like there's a number on by itself on the other side, you don't have to do anything with it.
You do. So, oh yeah, you don't have to like rearrange it or anything.
Okay.
So x is greater than negative 2. I find negative 2 on the x-axis right here, and it's just going to be a vertical line where x always equals negative 2. Let's see. It'll be a dotted line. And it says x is greater than that negative 2, so just lightly shading over here. Let's make a note. And then for the second equation, y-intercept at 3. Slope of 3/2 of 3 over 2. Down 3 over 2.
Okay, these on the test, you just have to like look at the graph.
You're just yeah, it'll give you 4 different graphs and ask which one's the right one. So you're looking at like dotted line versus solid line, and then the overlapping part. So y is greater than or equal to, so greater than this line, so the overlapping part is this section. Okay. 31. Rearranging these so that way I have them in a format that's graphable, preferably y equals mx plus b. So taking x, put it on the other side. And then for this one, this one was pretty easy. This one, I can't have that negative y. And when I divide by negative, we're going to have to turn the sign in the other direction. Okay, so there's our 2 equations we're going to graph for 31. I'm going to fold my paper so that way I can get it both in the same frame. 31.
Real quick, can you move the meat space?
Oh yeah, sorry.
Set.
Okay. Let's see. Okay, now graphing these 2 equations. Y-intercept of -2, negative slope. It's a dotted line for this one.
And it's just one slope.
Yeah, so but -1, so yeah, it's going down. Y is greater than that, so just kind of lightly shading here. Then the second equation, y-intercept of 2 and a slope of 3. And solid line. And y is less than, so it would be below wherever it overlaps. So the solution is this shaded area where it overlaps. Okay, one more and there's no graphing involved in the next one. On graph paper. Okay, so last one we're doing today, 32, which systems of equations is graphed right here? There's probably different ways that you could do this. We have all these answer choices down here. What I'm going to do is find the equation of each of these lines and then compare it to the answers. So here, this line right here has a y-intercept of 2 and a slope of 1. So that'd be y equals x plus 2. And then for this guy, it goes through the origin. So y-intercept is 0, and then the slope is up 3 over 1. So y equals 3x plus 0. So here's my 2 equations. These are in all different formats. That's cool. Okay, so you might want to rearrange it until you figure it out. It's not this, and it'd be nice if they were all in standard form, because then you could just put this in standard form.
The test answers be standard form?
It's B. Yeah.
It is B, but was there an easy way to do that?
Just add, just like add it to the other side.
Okay, I was seeing if there's a, because in my last class I just like rearranged it. Like this would be y equals 3x, and then this one, negative y equals negative x minus 2, which then you have to divide by negative 1. Yeah, it's B. Okay. Okay, the rest of the class you have to do Khan Academy. You can use your phone to do Khan Academy. And then we'll just continue tomorrow.